So shaking, blasting, and freezing might sound like something you do to make an ice cream sundae, but we're actually talking about how we test spacecraft. Hi, I'm Barry Noakes.
And I'm Scott Daniels.
We're here on the factory floor of Lockheed Martin Denver facility to talk about the tests that we perform on these spacecraft to ensure they're going to operate properly in orbit.
So it might help if I explain my group a little bit. So I work in ATLO. ATLO stands for Assembly, Test, and Launch Operations. So we're the group that's responsible for building, testing, and launching our satellites. We do things like blasting them with acoustic energy in our acoustic chambers. We heat them up and cool them down in our thermal vacuum chambers. We expose them to RF energy in our anechoic chambers. And we do all this to make sure that they're going to work properly on the ride to space and once they get there. Because they're well beyond the reach of human hands, after liftoff, we've got to test them thoroughly to make sure they're going to work.
Yeah, space is rough environment. We need to make sure the equipment operates properly when it gets there. As Scott said, there's no ability to repair the satellites, and so we use a test program that we refer to as Test As You Fly. We want to subject the spacecraft to all the environments it's going to see during launch and life of the spacecraft.
Right. So, for instance, just below us here is the pit. This is where we test the structure, or the bus, to make sure that it's structurally sound. So we'll connect a bunch of pulleys to it and tug on it, a high-stakes game of tug-of-war to make sure that it's going to work.
Sounds good. So we're going to go off to another facility and talk about the next step. Now we're standing inside one of the largest anechoic chambers we have here on the Denver campus. Anechoic stands for echo-free. It's very quiet in here, and sometimes you can hear your own heart beating. We use these cones on the walls to absorb the RF energy being generated by the spacecraft to make it a quiet zone. All the walls in the chamber here are coated with these cones.
We run through tests to minimize the noise and the interference from the vehicle to make sure that they'll be able to properly send signals back to Earth for things like satellite TV, broadband data, cell phone data.
One of the other major test programs that we do to spacecraft is we call it thermal vac. We'll take the entire spacecraft and put it inside a vacuum chamber. We'll pump all the air out of that chamber, and then we expose the temperature, the spacecraft to very wide temperature ranges. On a recent GPS spacecraft test, we exposed the spacecraft to minus 270 degrees F, very cold. In fact, cold enough to almost freeze air, and as hot as plus 100 degrees F.
So in addition to the static loads, the thermal vac tests, the anechoic testing, we do tests like the acoustic test, where we subject the vehicle to a large amount of acoustic energy or noise and make sure that we've properly put it together and it'll survive the ride to orbit. So I think it's fair to say that we put our vehicles through their paces here at Lockheed Martin.